TX Factor is brought to you in association with Martin Lynch & Sons, the world's favourite ham store.
Hello and welcome to TX Factor, the only TV show dedicated to everything radio, and starting this episode on a fishing boat. So what's that got to do with radio? Well, we're off to see a grand old lady of radio in the broadcast sense, but there is an amateur radio connection too. We're off to the Ross Revenge, which was the last ship used by the pirate radio station Radio Caroline.
You're tuned to Radio Caroline on 199, your all-day music station.
Wherever you go, go, go.
With Caroline on 259.
Go, go.
And as well as pirate radio, we'll be looking at another great British preoccupation, the weather. And more importantly for us as radio amateurs, how the prevailing atmospheric conditions affect our ability to communicate around the world using the HF and VHF bands. In the first of a two-part series, weather gurus Jim Bacon and Steve Nichols reveal some interesting facts about the weather and how we can work with it. But kicking us off in this episode, Bob joins Gary from ML&S with an overview on the current trends in digital transceivers.
Now on TX Factor, we're going to deal with the amateur radio mystery of the age, digital. Because I've got Gary here with me from ML&S. Tell us about digital, because it's, for a start, we don't quite know where to go with this because it's a bit like the Betamax VHS days. So there's three basic systems?
There are, yeah. You've got Fusion, you've got D-Star, you've got DMR radio, and they're all pretty much equal now.
We'll look at some of the radios in a moment,
yeah.
But imagine I bought myself a DMR radio. What can I do with it? Who am I going to talk to? Is it radio to radio? Am I connecting to the net? Am I talking through a repeater?
There's different things you can do. You can actually go simplex. You can talk to other repeaters. You can talk to clusters of repeaters. Some systems will actually allow you to actually then maybe even talk to one particular direct call to a repeater. There's just no limit, I think, to sort of some of the systems. Some allow more than others. With the things like the Motorola DMR sort of system, it's slightly more tied up. There's you've got the Brandmeister system DMR, which allows a little bit more flexibility. But there is other systems coming along like Phoenix, which again, we, as I understand it, will allow a little bit of flexibility. So,
and this is a community that's really being started and run and driven by radio amateurs.
Oh yeah, definitely. If it wasn't for sort of really excitable radio amateurs, I think this wouldn't be quite as where it is today. It's been fantastic. It's the fastest growing part of the hobby. Really has been the DMR.
Is it a bit more complicated though for somebody to start in? You know, you can buy your ordinary handheld, you pick it out of the box, put in a repeater frequency, and off you go.
I'm not going to lie to you. It is a little bit. It is a little more complicated. You do need to have what they've coined as a code plug. It's where you create zones, and they're basically groups of repeaters, and within each of those repeaters you have talk groups, and those talk groups then will have contacts actually embedded in them. So then you program that whole thing to the radio, and that will give you your code plug effectively, and that will make the radio work. You can download those. There's loads and loads of user groups around now, and loads of people that will we'll do that for you. It's not, it's not a problem.
So again, the real spirit of amateur radio, isn't it, Gary? Getting into something new that we don't know about and getting somebody else to help you out and show you the way through.
Radio hams have been absolutely brilliant. I mean, in general, a lot of people now are really getting into writing these code plugs, and it's almost like they're 15 minutes of fame. They're starting to give away the code plugs, and it's fantastic. It's really, really good fun.
So let's have a look then at some of the radios that you have here at Martin Lynch & Sons.
Okay, well, I think we'll probably start with the most popular radio, which is the mobile. Those are extraordinarily popular. They're fantastic, easy to use.
Can I pick it up?
Yeah, of course you can.
Well, because it looks like it's good. Well, it is. It is exactly like it looks. This is heavy.
Yeah, they're very well built. They're intended for the professional market. They, and obviously as hams, we've now taken them on board, and as I say, they've been very, very popular.
You were telling me about the tests they do on these in the factory.
Oh yeah,
in China.
they drop them on the floor. But
is that okay if I drop them?
No, definitely not.
Put it back there.
No, well they do test them like that, and they also freeze them and do all sorts. But
so tough because they come from that background.
They're very tough. Yeah.
And you can see that in the handhelds as well, can't you?
Yeah, I think my favourite is a 785. This is a very, very chunky radio. It's text messaging. What else do they do? Direct call, simplex.
So if we buy one of these, then Gary, we've got to get it programmed up with our code plug and work out what we're using it for, which repeaters we're talking through, or whatever. We can get that all sorted, and away we go, and we can start experimenting too. And that's a key word, something that's been missing a bit from amateur radio in some senses recently.
It's a lot of experimentation going on, and this has driven a lot of things forward. And it's lacking a little bit with DMR because it's more of a closed system. However, with the new networks now that are just popping up, it is allowing for that little bit more experimentation. For instance, some of these have GPS. They will allow you to play with the GPS settings. They will allow you to send sort of data and text messaging, which is really, really good fun. I think it's just going to that's what sets digital, I think, apart from maybe analog.
What would this one cost us then, Gary?
I think this one's actually 369. It's around that sort of price. This is the PD685. This is, again, one of my favourites. This one is built in GPS, and it has an awful lot of functions. But it's also, if you look at, say, the radio, there's a big difference.
It's a lot thinner.
Yeah, but it's quite a heavy radio. I mean, if you want to feel the...
Yeah, that's still quite heavy, isn't it? And you've got the small little lightweight one here.
Yeah, that one's a PD 365, and that one's the entry level into the high tier range. There is another model coming out, which is, or is already out, is a 375, which is maybe an uprated version of this one.
And the other brand that you have is this one. Tell us about this.
This is the TYT MD380. This is a fairly recent sort of addition to the market. It's a budget radio. It's you get what you pay for. The audio's not quite so good. The maybe the transmit audio may be a little quiet or whatever, but it's a good start into the radio, into sort of the DMR sort of side of things. It comes free with a programming cable, and there's lots of people out there at the moment that are doing code plugs and even, dare I say, firmware modifications, which mean this is just a really good radio. This one's good. It's an exciting little radio, really, for the money.
And you're selling a lot of these.
Yes, we are. Yeah, they're very, very popular.
Thanks very much, Gary, for that brief introduction to DMR, and I'm sure it's a subject people would like to find out more about. You're here at ML&S, and you can happily talk to people about it. And as you said, there's a lot of user groups, a lot of information out there. But before we finish, there's something I've spotted running on this screen over here. What's this?
This is a Raspberry Pi running a DV4 mini dongle, just sitting here really minding its own business. But that's it. That is.
So that's the Raspberry Pi here, and so this is just a standard Raspberry Pi 2.
It is, yeah.
It is a 2.
Yeah, it's a 2. Yeah.
Yeah.
It's a very basic Pi sort of setup. The only difference is that we've put the Raspberry Pi Wi-Fi dongle in. It's got the DV4 mini dongle itself.
Well, the beauty of this is, though, that this is not just one digital format.
No.
How many formats does this do?
Well, you've got D-Star, DMR, DPMR, and obviously C4FM, which is Fusion, and you've got P25 there. D-Star is pretty much D-Star. It will allow you to connect to various reflectors and X-reflectors on there, and it's a really easy way of using D-Star.
And the point about this is, with that dongle, that's connecting you to the net, so you can then connect to all the different repeaters, user groups, etc., on whichever format you're using. So you can set this up in your house, and then you can use your handheld, connect to the world.
Yeah, the only thing that you need to remember is that for every mode that you need to work, you need a handset in that, or a radio in that mode.
So if you're a D-Star user, you select D-Star, use your D-Star radio, and you're into the D-Star network, or whichever one it is. So what's the transmit power of the dongle?
It's 12 milliwatts, and that will give you a more range than you expect, but it's not going to be huge.
So around the house, but it does lead to some questions. This has been raised by the RSGB in their news bulletins recently in RADCOM, and that's a question of NOVs. How does an NOV apply to this?
Well, because obviously you can pass third-party traffic, or potentially pass third-party traffic. And what we did was we spoke to Steve at the RSGB, and we've actually enabled, now it will actually lock to your own call sign. So it will only accept your call sign on D-Star and DMR.
So using this on D-Star and DMR with that ticked, then you don't need an NOV because you can't pass third-party traffic.
That's correct.
If it's not ticked, then essentially you're a gateway and you need an NOV.
Yes, and you need an NOV. And that goes for pretty much all of the systems, including, say, Fusion with the HRI 200. You'd still going to need an NOV for that, because, as I understand it at the moment, we can't lock it to one call sign at the moment. So, it is causing a little confusion, but we are working on it. And, most of the companies accept that this is a bit of a licence quirk, and we really need to get it sorted. So
there we are. Remember, keep it legal.
Still to come on TX Factor, a look at how the weather affects radio propagation, and a life on the ocean waves, and a look back to the UK pirates from the swinging 60s. Yaesu and Martin Lynch & Sons are proud to present the latest 100-watt HF 6-metre multi-mode mobile transceiver, the FT891. It offers a large LCD display, including quick spectrum scope function, and a rugged ultra-compact body. The FT891 comes with a 3 kHz roofing filter as standard, and triple conversion with a first IF frequency of 69.45 MHz to hone in on that rare DX. The faceplate is removable, and separation kits are available. And ML&S are now offering the superb SDR Play receiver, a powerful wideband full-featured SDR with a frequency coverage of 10 kHz to 2 GHz. All you require is a computer and an antenna to enjoy 10 MHz of spectrum displayed monitoring. With open source API, you can even create your own application, and it's available from stock. Martin Lynch & Sons, the world's favourite ham store.
Hello CQ, this is Golf Kilo Zero, Foxtrot Golf X-Ray. Golf Kilo Zero, Foxtrot Golf X-Ray calling CQ. CQ17, Golf Kilo Zero, Foxtrot Golf X-Ray listening. Oh well, not a lot happening there. Mind you, of course, I could be completely on the wrong frequency for this time of day. So where can we look to get the right information about which band we should be on and when? Well, one very useful resource is the propagation forecast contained in the GB2RS News Bulletin. And of course, you can hear that every week, provided by the local amateur radio station that reads that in your area, or you could listen to the TX Talk podcast of the GB2RS News, which we put on our website every week. Now, I could have gone and had a look at that because it's also available in transcription form. If you go to the RSGB website, you can read it as well. I thought I might get some useful pointers. And then I thought, hang on a minute, why don't we get this straight from the horse's mouth? So I headed off to the University of East Anglia, where Jim Bacon is based. Now, he, of course, is the well-known TV meteorologist. He knows all about Earth weather and how it affects UHF and VHF propagation. Also there to meet us was Steve Nichols. Now, Steve is an expert on space weather and how that affects HF propagation. And the two of them are contributors to the GB2RS propagation forecast. Steve, do you think that amateur radio operators generally understand enough about the mechanics of propagation, and should we really understand more?
I'm careful how I answer that one. I don't think enough of us do, and I think it is vitally important because you get your license, you get your radio, you get your equipment, and you want to talk to somebody in a particular region of the world, and the only way you're going to do that is have a knowledge of propagation, to know what band you should be on at what time, in what time of year even, to be able to do that. And I think if you don't have a basic knowledge of propagation and what causes it and what drives it, then really it becomes more of a bingo calling match, really, that you're just shouting and not knowing what's going to come back at all. So I think a knowledge of propagation of all time, depending on what your interests are, is vitally important, to be honest.
Yeah, but I suppose, Jim, it's a deeply scientific subject, this, isn't it? Do you think that the average radio amateur might be just scared off and think, it's all too complicated?
Yes, I think it's always easy to think something is too difficult, but actually it's like a lot of things. If you take time to spend an investment of your time, just a small amount, it's amazing how much more interest that particular subject can be. And it certainly applies to propagation. It's a bit like deciding you're going to go fishing and just saying, oh, there's a river, I'll cast my float there. And you may be lucky, you may not. But if you understood how fish behaved and where they fed and what they fed on, you would have a better result. The same is true, I feel, of propagation. That amateurs can get so much more by understanding just the basics. It is a complex subject, but that's why it's good that amateur radio has access to professional researchers, professionals working in the subject, and amateurs who can pool the resources to actually distill out just enough to make it that much more interesting. And after all, how much better would it be if you could say, I worked market reef on 6 metres yesterday morning? Well, why was that? It was because of sporadic E, and that works because of so-and-so. These are things that make it much more interesting, and there's no substitute for finding out more about how things work.
So it's up to us, the amateur radio operators who want to understand more about propagation, to help you and the rest of the amateur radio community by matching up our experiences on the bands with your propagation forecast data.
Yeah, we've done a lot of work in the past in this field. I mean, when we had the total eclipse a couple of years ago, we set up a number of experiments. We also had a contest that was going on that day where people could take part in the contest or take part in some of the QSO parties that were going on to gather data on what effect the solar eclipse had. And we've got a massive amount of data that could be used for research in that way. I mean, sporadic E is the same. It's only by observing what contacts are being made and then comparing that with models, we can see whether we've got the model right or not. And nowadays with the internet and tools like Reverse Beacon Network, PSK Reporter, and DXmaps.com.
And others like it.
And others like it. That we can actually see in real time what people are working or how people are working each other. That we can actually compare that to our model and go, yes, the model's right, or we need to do some more work on it.
So, Jim, I suppose it is all about the weather, really, with propagation, both HF, VHF, UHF, but as the frequency goes up, the weather we're interested in is lower down.
Yes, it often seems a bit counterintuitive, really, that should be the case. But the more radio waves approach the frequencies of light, for example, the more you realise how important small, minute changes in the atmosphere are. And I know in Radcom there have been some articles recently on light communication. And that just shows how interlinked this is. This whole electromagnetic spectrum is all-encompassing, really. And for my part, the interesting thing was that going around various radio clubs doing talks about tropo and the normal things that we take for granted on VHF as giving us enhanced conditions, you find that nowadays modern meteorology is not just able to measure the state of the atmosphere in the lower layers using these radiosonde balloons and get a very accurate profile of essentially what is temperature and moisture content in the atmosphere. And those two, as it turns out, affect the refractive index of the air. And if you change the refractive index of the air, it's a bit like, putting your pencil in a beaker of water. It will appear to bend. The same thing happens to your radio waves. So we can say a lot about why conditions, how we normally describe, have a bit of a lift on a given occasion. But what is interesting now is that the mathematical models that are increasingly being used to predict the atmosphere going farther ahead in time are really very good at finding those sorts of features, not just for today or tomorrow, but out for the next 4 or 5 days, or even to 10 days ahead. You can look at a map and you can say, there could be some good tropo down to the Azores on that day. And that's something amateurs would never have dreamt of being able to do even only 30 years ago. So it's a fantastic time to be an amateur, because you not only benefit from science and the professional arm of science, but you also benefit from the amateur part of science, where that knowledge, and as Steve said, the contribution of amateurs' logs into things like Make More Miles on VHF, DX Maps, the 6 metre website, their user group website, has some fantastic displays of where the current openings are. That stuff should be gold dust to all VHF and UHF operators. And what I'd like to say, or like to see, shall we say, is more amateurs being used to using that, to get that extra little bit of excitement and knowledge from the hobby, because it's out there and it would be lovely if it were used more.
Steve, it's very different, isn't it, for you? Because for Jim, his experience as a meteorologist helps him with his understanding of the weather here on Earth. But for you at HF, it's all about space weather. So that's a very different scenario, isn't it?
It is a different kettle of fish. Jim is interested in what happens perhaps in the first 6 or 7 miles. We're interested in what happens from 50 miles to 300 miles, effectively, and also what's happening at 93 million miles away. We're interested in what's happening on the sun. The sun is what really drives ionospheric propagation. So we need to know what's going on with the sun in terms of its electromagnetic output, that's in terms of ultraviolet. We also need to know what's happening in terms of particle output. Once we get a handle on that, then we can try and work out how that then affects our ionosphere. And only then can we then start to plan, what band should I be on at what time and why. I mean, somebody said to me the other day, I don't get this. He said, on 40 meters, I can talk to somebody in Germany, say, but I can't speak to somebody down the road. Why? Well, once you start to understand propagation, you know that your signals go straight up and come back down again if there's enough ionization. If there isn't, it just carries on going into space. But as that angle comes down, so you're not going straight up, you're coming down at a more oblique angle, then there will be a refraction and reflection. It will come back down again. So we need to understand something called the critical frequency, the frequency at which signals that are going up come back down again or don't come back down. Once you understand that, you begin to see why 5 megahertz is so good for conversations around the UK, where at times of low sunspot activity, 7 megs is no good at all for that, but at high sunspot activity it is. So that's just one example of a basic understanding of propagation and the solar effects means you can then plan what you want to do.
So how do you get the money for that, Steve? Because I imagine that in these times of climate change, the research money is going into research into earthbound weather, whereas for HF, professionally at least, the interest is dying away a bit, isn't it?
There's a lot of interest in the sun and what the sun is doing, and there's a lot of money thrown at that by the various authorities, because that could have a drastic effect on satellites, it could have a drastic effect on life on Earth. So there's a lot of information about what the sun is doing. There's less information about what is happening with our ionosphere, for the reasons I said earlier. But we are lucky enough in this country that we've got 2 digisondes, or ionosondes, that probe the ionosphere and tell us what's going on. We've got one at RAF Fairford, we've got one at the Rutherford Appleton Laboratory at Chiltern near Harwell, and that every, I think it's 5 minutes, probes our ionosphere to see what signals come back. So from that we can tell what the critical frequency is. From that we can then say what would be the best band to talk to people around the UK, and from that we can also infer what the maximum usable frequency is over a longer path, say 3,000 kilometres. So we can look at that and say, right, okay, 20 metres is going to be the best band to use for that. So we're lucky enough we've got these professional tools that wouldn't otherwise be available to amateurs to actually do this kind of work.
For you, Jim, it's a perfect combination, isn't it? Your interest as an amateur radio operator and your professional expertise as a meteorologist, which gives you access to raw data regarding VHF and UHF that the rest of us don't have access to. So how do you begin to put together your propagation forecast for GB2RS?
Well, there are 2 components to it. The first thing is the general assessment of what the weather's actually doing, so where the highs are, where the lows are, and so on. And that is done by looking at all the normal charts that are available on the web for locations of high pressure, low pressure, where the weather fronts are, and so on. And then one needs almost a special knowledge of what that implies for certain types of properties in the atmosphere, which we call temperature inversions, and they tend to belong with areas of high pressure, and they have the effect of causing layers in the atmosphere. You when you look at the sky, you see either tall bubbly things, clouds that produce showers, or you see layered cloud, which tends to be uniform over a fairly large area. And what I think we're looking for in tropopropagation is the sort of weather pattern that produces either visible layers of cloud or clear skies, lots of sunshine, but there are invisible layers that you can't see in the temperature structure of the atmosphere. And one of the things I have on here is the result of sending a balloon up through the atmosphere carrying a package of instruments which actually measures a temperature profile, and the dotted line here is a dew point, which is a way of measuring how much moisture there is in the atmosphere. And you can see it varies a lot, which is actually what you might expect if you go through different layers of cloud. The actual temperature shows that mostly it's falling. This is the falling direction. And here it's just rising slightly, and that's what we call in the trade a temperature inversion. So instead of it normally falling as you go up in height, it's rising slightly, and it has the effect of causing a layering of the atmosphere. It's a bit like when you see smoke coming out from a bonfire, goes straight up for a distance and then spreads out horizontally. And on this radiosonde descent, as we call them, you can see a dry layer here with a very moist layer just below it. And when you get that contrast, that has the effect of changing the refractive index of the air and forming what we call a duct, and that duct will be what bends your radio signals, and you can get captured in that duct, and your signal could go from, say, southern England right the way across the North Sea to Denmark or so on. Lots of DX opportunities there for what is essentially just a temperature inversion causing a layer of moist air to get trapped below a layer of dry air.
That's really interesting. So it's not about being high up to take advantage of a temperature inversion. In fact, you want to be lower down, and I imagine it would be possible to be too high.
And the point about that is the traditional theory in VHF, if you wanted to put on a VHF NFD station, one might think, oh, let's go to a nice high hilltop and get good path to all parts of the country, get multiples bonuses for different countries and so on. So you go to a nice high hill. But these temperature inversions that we're talking about here quite often form near the surface. There's one very low one right down near the bottom of the surface there, and that can form at night. And it's the sort of thing you'd see in the morning when you wake up and you look out over a valley. I don't do that sort of thing very well in the fens of East Anglia, but other parts of the country you'd be able to do that. And you'd see down in the valley there's all this mist and fog, and that's trapped underneath one of these temperature inversions. Now what happens is you go on the top of the hill, you're going to miss the benefit of the duct because you'll be above it. And for example, you might say, if you lived in the home counties near Luton, you might say, oh, good conditions today, I can hear the repeater from the Midlands. Let's go up onto Dunstable Downs and work some DX. And you got a lovely sunny day up there, but the lift had gone. It hadn't gone, it was below you, it was where the fog was. And that's the thing, you've got to stay below the inversion. And it, unfortunately, for Tropo, probably means staying in the mist and fog.
Oh, well, that'll work out all right for me, Jim, living in West Cornwall as I do, because we get a lot of fog there. Another aspect of propagation, which seems a bit like black magic to most of us radio amateurs, because we don't understand the mechanics behind it, is sporadic E.
Sporadic E is fundamentally one of those things which has almost as many weather sayings as weather does. It's you wait till there's a meteor shower, or you wait until a certain week of the year, or so on and so forth. It's hugely variable, and it was because I kept getting asked questions about sporadic E and the most likely causes that I realised I really don't have a clue what is going on, what causes it. Sporadic E as a mode, it's basically an intense but very localised patch of ionisation in the E region. Doesn't happen everywhere, and it doesn't happen all the time. It's a mainly summertime phenomena, so it's sort of May through to the end of August usually. It can happen outside of that, but it's much rarer. It can peak or appear to peak twice a day, once in the late morning and again in the late afternoon, early evening. So that's a bit of a quirky thing to explain. The business about thunderstorms crops up with a few folk, and there was a very major opening one year which I looked at after this question, not a cloud in the sky, let alone a thunderstorm. So if it is thunderstorms, it isn't the only show in town. And there was a period of research from, I think, the east coast of the States, where they managed to get a rocket launched into a sporadic E cloud, and it came back with samples of particles from that altitude. And what they found was that sporadic E clouds seem to compose a lot of iron, magnesium and silica ionisation. Now the question then has to be, where does that come from and why is it there? And it turns out that that kind of adds a bit of background support to the meteor idea. That when meteors burn up in the atmosphere, if they're composed of these elements, that's what the ionisation will be. It'll be ionised meteors when they burn up. And the point about that, as it turns out, is that the ionisation produced by meteors lasts a lot longer than the ionisation that, say, makes our normal F layers and so on. Because if you ionise the gases that are up there, they recombine in a very short period of time, a matter of a second or so, or even shorter than that. So it's very small amounts of time. This is several tens, if not hundreds of seconds. Now the other thing that happens is you've got to say, well, why is it twice a day? And why does it only happen in the summer? And why does it happen where it happens? What makes that place different to anywhere else? And it turns out that when they've looked at these events, there is a close correlation, and there's a theory, in fact, that's often misquoted, but it is the wind shear theory of sporadic E. But what happens is, the atmosphere low down, where I live, you know, where I have my craft, is driven by things that are by nature turbulent. So a cold front whistling across a chart is a turbulent place. A thundercloud is a turbulent place. A jet stream, this current of fast-moving air at about the height that airliners fly, is a turbulent place. And some bits of that are more turbulent than others. Well, mountains also, they're not in themselves turbulent, but they cause turbulence to the air flowing over them. So there's all these things going on in the weather bit that can be important. And it turns out that when you disturb the atmosphere with this turbulence, you create what we call gravity waves. Now that sounds like a very space science fiction thing. You're not zapping somebody with a gravity wave, but what you're doing is you're looking, say, on a pond, you throw a stone into it and ripples run away from it. That's a gravity wave because the gravity is the restoring force for that wave motion. It wants to bring the particles down again. When you get to the E layer, this is where the wind shear theory comes in, because if you get wind going in one direction at one height, another direction just below it, that is a definition of a wind shear. A wind shear could be a shear in direction or in speed. Well, if you've got wind doing that and you've got all of this lovely stuff from meteors, that's a charged particle, this ionisation from the meteor. So when the wind blows it this way, it's blowing a charged particle through the Earth's magnetic field. And you know the malarkey of having your, well, that will be deflecting that particle in a certain direction. If you have the wind blowing in the opposite direction, it'll deflect it the other way. So what happens is, in the E region, the gravity waves, when they come up from below, will get the meteor debris and in the right conditions will converge it together to make a much more dense layer, and that is what reflects your signal. And when people are hearing sporadic E, they're hearing just these brief moments when the path is right for where you are, and somebody 20 miles up the road won't hear that signal at all. There'll be end stop on your meter, but the geometry is just right. And as the wave where the E layer is doing the reflecting moves along a bit, somebody else will be getting it. So that's what sporadic E is.
Now we know. That's a brilliant explanation, Jim, to help us get our heads around it. But the next thing that follows on from that is then how do you put all that together to get a propagation prediction?
Well, I'll have to come clean here. We can't really predict it, but we can say this is the best bit of the river where you're more likely to catch something. Some days it'll come off, some days it won't. But it does save you wasting a lot of time in the shack when it's never going to happen. And what, for example, I do, here at WeatherQuest, we have access to a lot of model data. And my colleague Dan Holly has put together a set of 4 charts, which I use to look at the different times of the day, 600, 1200, 1800 and midnight. And it plots what is essentially the flow of the weather pattern at 300 hectopascals, which is 30,000 feet, roughly speaking, where the jet stream is. So what happens is the green colours represent jet streams. And you can see, this is today's chart. We're filming here, middle of August. And you can see that in what is a summer month, there's still lots of jet stream activity about. And On a good year, you can get some very strong, we have to bear in mind, a good year for radio amateurs is not necessarily a good year for the holiday industry, but on a good year for radio amateurs, there are nearly always lots of jet streams within Europe. They won't always produce geometry for a path for Britain, because this is a height of about 100, 120 kilometres, and if the jet stream is too far away, no matter how good a position it is, it won't allow you to get into it because the distance is wrong. So you'll get times when everything is right for one part of the country but not another. So this isn't like saying sporadic E works for everybody all at once. It is so localised, you wouldn't believe how localised it is. It's like you're shining a torch on the roof of the room, and you tilt it slightly so it makes an ellipse, and that ellipse is the zone that can hear the other station. And not only that, you're shaking the torch. So there's a lot of hit and miss about it, and some of the things don't all come into play. But jets, I have to say, over the last 3 years, looking at all of these other potential elements like thunderstorms, mountains, they're quite good, but jet streams, by far and away, the best indicator of where you might find sporadic E located geographically. And particularly good are where jet streams interact with mountain ranges. So this set of charts shows you during the day, because these weather patterns evolve, it's important not to look at it at a fixed time, you're seeing things moving. And here we've got the green pattern shows a jet stream. Even the pale green can do it if it's associated with going over a mountain range like the Pyrenees or somewhere like that. The red areas and the blue areas we've put on here, it appeared that sometimes these jet streams are more effective than others. So then we've got the main jet stream coming in from the Atlantic, which is also powering down into Europe and impacting on the Pyrenees here. There's elements of it that are going to affect the Alps as well. There's a strong jet stream in the eastern end of the Mediterranean through much of the summer, actually, and that's been instrumental in paths between Israel and the Balkan states up here. You can get paths across the Mediterranean, and then you might ask yourself, what about all these boys on 6 meters who work Japan over the Northern Pole? Well, in the right time of the year, you can get these patterns that are present up over the Arctic Circle and provide a very good loop for that, as well as diving down over here. So the areas surrounded in red are areas where the pattern is moving quickly, or the height, this value that the contours represent, is changing quickly. And that is a particularly important area for turbulence. So the red areas and the blue areas show regions where either the pattern is moving or the value of the pattern is changing quickly, and that means that you're going to get more turbulence generated in these regions. There's been some limited stuff there today. I just checked a minute ago on DX Maps, and other of these cluster display map websites are available. This one shows sporadic E paths in red, and Gabriel Sampol's site is looking at all the different bands, so you can see which ones are more active. And that's picked up an opening appropriate for this time, midday, which is going across the bottom end of this jet stream here. And that's quite an interesting thing, just a single opening. But it's because we're late in the season. If you were in the middle of the season, they would tend to be more widespread things going on.
That's a really interesting connection that you've made there, Jim, between the cluster site and your chart, because that's how we're going to take this forward, isn't it? That's how we're going to get a better understanding of the connection between what we experience and the explanation behind it.
Steve and I, from the propagation angle, would both have to say you can't stress enough the importance of contributions from amateurs to the understanding of propagation. And it's over the last 2 or 3 years that people who contribute to those websites that display the paths allow you to fine-tune which of these areas is most important. And this map of the jet streams is placed on the RSGB forum every single day of the year, so you can even study it yourself and look for those out-of-season events. But during the main sporadic E season, I also write a blog each day that explains why I think different areas are more significant than others. So people can start to get involved, see what's triggering it. See, sometimes things won't work out, but sometimes they will. The ones that don't work out are just as interesting as the ones that do, Because just when you think you've got a rule, you realise there is no one rule that fits all. When you look at the schematic of the things that at the moment our understanding is affect sporadic E, you'll see it can never be solved by just following one thing. There's been some interesting work done on the climatology of sporadic E. And that comes not from just the random nature of amateurs going into the shack and being available, but it can also be done from the vast network of satellites that are up there that are monitoring conditions constantly. And there's been several studies done, 5 or 10 years ago, I think in Germany is one that I saw papers from. You've got this wonderful climatology showing how sporadic E varies over the whole spread of latitude bands, from season to season, from year to year, how the southern hemisphere season obviously is a different time of year to the northern hemisphere because it's summertime phenomena, but how there may be some linkage, that when we got week one year in the north, you get a following year week one in the south. It's also a case that you can look at it in terms of the latitude band that sporadic E is more likely. And that shows up some interesting things to do with the angle of the Earth's magnetic field, has a lot to say in this. So you need to be a certain distance from the geomagnetic equator. You don't get sporadic E over the geomagnetic equator. It can only happen in a certain latitude band either side. So all these interesting things, loads of resources out there. It's just getting hold of them and finding out where they are.
Well, I don't know about you, but I learned a lot from that. And as you can see from that chat that we had with Jim, it's a massive subject, which is why we decided we weren't going to be able to squeeze it all into one episode. So in the next episode of TX Factor, we'll be talking to Steve Nichols about space weather and how it affects HF propagation. And don't forget, if you'd like to find out more, check out the show notes at txfactor.co.uk. Now, an interesting experiment in propagation, because I, for the first time anywhere in the world, I'm going to see if it's possible to get propagation into the past. Now, to do that, I need to tune the radio here to about 199 meters, medium wave, and see if we can find... On Easter Sunday 1964, a radio legend was born as Simon D made the opening announcement for the UK's first ever offshore pirate radio station.
This is Radio Caroline on 199, your all-day music station. We are on the air every day from 6 in the morning to 6 at night. The time right now is 1 minute past 12, and that means it's time for Christopher Moore. Radio Caroline.
Broadcasting from the ship the MV Caroline, the station was the brainchild of Irish businessman Ronan O'Reilly.
Sounds fine, it's Caroline.
Radio Caroline got on air just ahead of a rival radio station, Radio Atlanta, which broadcast from a ship called the Me Amigo. Rather than compete, the organisations joined forces. The MV Caroline sailed north to become Radio Caroline North, and the Me Amigo became the home of Radio Caroline South. Previously, UK music lovers had to make do with a very staid BBC light programme. Instead of announcers, Caroline had fashionable young DJs like Tony Blackburn. He and his colleagues, such as Johnny Walker, were treated like pop stars as the station's audience grew to several million.
Caroline, the sound of the nation. Caroline, the sound of the land. Caroline, the sound of the nation.
The Me Amigos' powerful transmitters beamed non-stop pop across the UK and Europe, outlasting the government's outlawing of the pirate radio stations and only being silenced by a financial dispute with the Dutch shipping company in 1968, which saw the Caroline North and South ships towed into port. But it wasn't the end. In 1973, Radio Caroline made an unexpected comeback from the Me Amigo. With quite a few dramatic ups and downs, the Me Amigo remained Radio Caroline's home until one stormy night in March 1980, the old ship finally succumbed to the North Sea. Stevie Gordon and Tom Anderson were the last voices broadcast from the Me Amigo. Fortunately, all of the crew were safely rescued, but for Caroline, it seemed the end had finally come.
Radio Caroline. The legend lives on.
Then, in August 1983, another amazing comeback. Radio Caroline was back from a new ship, the converted trawler, the Ross Revenge.
319 Radio Caroline.
As Tom Anderson was the last voice heard from the Mi Amigo, he did the first regular show from the new ship. The Ross Revenge remained Caroline's home through the 1980s with many a drama, including a raid by the authorities in the August of 1989. Finally, she fell silent on the 5th of November 1990. But thanks to a Caroline enthusiast called Peter Moore and a team of dedicated volunteers, the legend lives on. I'll tell you what, this is fulfilling a boyhood dream for me, because when I was a kid and lived in Southend and listened to the pirate stations, I used to dream of being a pirate radio DJ. And here I am, on a tender, heading out to Radio Caroline. How amazing is that? The Ross Revenge still hosts some Caroline broadcasts and now sits at anchor on the River Blackwater in Essex as a living memorial to the station that changed radio in the UK forever. We all know that if you want to get a good signal out there, you need a big antenna, so it gives us a bit of a clue as we're looking around at the boats here to see which one might be the Ross Revenge, because there's one there that's got a very big mast on top of it. We're here. Now all we've got to do is get on without me or any of the crew falling in. You're not going to fall in, are you? I hope not, because that camera's expensive. Right, you go. Oh, whoops. Fantastic, here we are. We're on the Ross Revenge, and I've been waiting since I was about 15 for this. Get a great view from out here as well, and I think probably a bit of a better view than the guys had when they were working on this as a broadcast station, because they were further out and in some pretty rough water at times, whereas here we're sheltered in the estuary watching the other boats go sailing by. It's a traditional Essex fishing smack.
Golf Bravo 5 Radio Caroline on board the Ross Revenge, calling CQ40 and standing by.
Good afternoon, hier report is 59 plus 20 dB, Nähe City Dresden, name here.
Ah, Tony.
Good afternoon, welcome on board.
Well, thank you. I've just been telling everybody this for me is a dream come true. You know, I listened to Caroline when I was 9 or 10 when it started from the Mi Amigo. In fact, I even heard that first broadcast Easter Sunday 1964 because we read about it in the paper and the family were all listening to it. What a big impact Caroline had.
I don't think people realise today with all the, as you say, all the different choices and stations, but up till 64 Easter when it started, there was only a few hours of music every week. Once Caroline came along, they had 168 hours every week they could use, so it made a massive indent into the music industry.
Yeah, it must have been incredible, because suddenly it was the age of the teenager, they're just coming to the fore, and suddenly they've got an all-day music station. It must have been amazing.
And if you look between 64 and 67, some of the classic all-time music is in that block, because they had a huge database of music to pull from most people hadn't heard before. So in those 3 years they were popular, a lot of it was played, so you got to hear a lot of new music very, very quickly.
And of course Caroline's had a fairly checkered history, hasn't it? Because it started off then as a big money-making machine, and then later on went to be a big money-losing machine, but kept on air by the passion of people like Ronan O'Reilly and all the volunteers and all the people who've been involved
I think
since.
that is, it becomes an obsession and a love, and that's why it's just continued with supporters looking after the boat and the name of Caroline, so it's still on today, even though it's only internet-based. It's still something that's considered very special by a lot of people.
So when was the last actual broadcast from the ship?
This boat came on air as their 5th boat for Radio Caroline in August 1983 when it dropped anchor in the North Sea, and I think the last broadcast was October-November 89 roughly, and that was the last time it transmitted free from international waters because the law changed shortly afterwards.
And I think it has done some broadcasting since it officially ceased being a pirate, hasn't it?
Yes, there's been many different broadcasts, and at the moment, once a month, there's an internet broadcast done from the boat live that goes out on Manx Radio via the internet, so they actually still come on board the last weekend of every month and use the Caroline boat as a base for the broadcast.
So how did you come to set up this special event station for the first time?
Well, I've been interested in helping out, coming along as a supporter to the boat for many years on and off, and we were speaking as amateurs, could we do something different from the boat? A lot of people would know it would draw a lot of interest, so we spoke to the station manager and others, asked permission, explained what we were doing. Keith G6NHU checked with Ofcom that we could have a licence to do the broadcast, and it all sort of come together, and here we are this weekend.
And the interest in it from around the world has been amazing.
Oh, it's phenomenal. It took us quite a while last night to set all the antennas up, so we didn't get on air till just after 5 p.m, and we ran through to about 12:30, so it was on for about 6.5, 7 hours. We worked 700 people last night in the first evening, and now it's early afternoon on Saturday, so it hasn't even been 24 hours yet, and we're up to 1,300 and something contacts. I don't know how many countries, but there's 1,300 contacts so far.
And how many of those had heard of Radio Caroline?
I would say 19 out of 20 were more than aware what it was. A lot of them have been saying they've got photos of Caroline, they listened to it, they've got a friend who's been on it, etc. It's very rare to find someone who doesn't actually know what it is.
And for us radio anoraks, it's the technical side of it that fascinates us, the idea of running a broadcast station from here. So talking about the broadcast transmitters, we'll go and see those in a minute, but they ran a fair amount of power into a very big mast, which is up above us here.
This is just a copy of the original mast. The original mast fell over the side in a storm towards the end of the 80s. That was a 300-foot tower.
Whoa.
So they could have a proper quarter wave on the frequency they were using on medium wave. Downstairs they've got RCA transmitters that gave out 50 kilowatts on AM, so their main transmitter was 50 kilowatts up a base-loaded vertical.
What antennas are you using then for your HF and VHF special event station?
We've got one dual band collinear for 2 and 70. But on HF for 10, 15, 20 and 40 we've got quarter wave verticals all separate, and on 40 metres we've got a wide dipole, and for 80 metres we've got a wide dipole to switch over to in the evening. So we've got quite a selection of aerials to use throughout the day.
And you're benefiting the same as they used to with the broadcaster being sat here on this salt water?
Yes, we've noticed today just running 300 or 400 watts on 40 metres for example, the signal reports we're getting are phenomenal around Europe compared with other people, simply because if you look around us, the ground plane we're sitting on is miles and miles wide.
La 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 la, the station that's all heart, the station with the happy difference.
So, the transmitter room.
Yes, this is the main RCA transmitter that Caroline used. It's a 50 kilowatt AM transmitter that they used on 963 kilohertz when they came on the air for the first time. It's unusual in the type of way it generates the modulation.
So these aren't the original Radio Caroline transmitters because they're at the bottom of the sea with the Mi Amigo.
Yeah, when this boat was fitted out in Spain in 1983, these new RCA transmitters were put on, and the way they generate audio is ampliphase, which makes them a little bit different from standard medium wave transmitters.
And is there just one transmitter?
No, the cabinet is broken into two, so 25 kilowatts is generated in the first half and 25 kilowatts in the second half, and they're strapped together with a copper T-bar across the top where the 50 kilowatts is fed to the next cage.
This place must have been alive with RF.
Yeah, quite
How
warm
did they
down
keep
here.
it out the audio gear?
I don't know, it was just shielded well and we're in a metal box.
I suppose so. Come on then, let's have a look at a 25 kilowatt valve.
This is one of the original ones that has been on the boat since 1983, and this is just one of two that are strapped together to generate the 50 kilowatts that was the maximum capability of the ampliphase RCA transmitter.
You can't really underestimate the technical challenges of doing this in this location.
Especially when it rocks about at sea, but it didn't seem to cause any problems. So
And you've got to have the generating capacity to support these powerful
There's two large generators next door which they run one week, one then the other, so they always have the power to supply them. But it burnt a lot of fuel. I think it was around a tonne a day of fuel that they needed to run the station.
So that's one of the real difficulties for supplying the station, because after the Marine Offences Act, when the stations couldn't be supported from the UK anymore, you had to get the fuel in from a long way away, and not as frequently, I would have thought.
So it's got massive water tanks, massive fuel tanks, massive storage for food. So yeah, if it was full up, it could last for months and months and months.
Amazing.
Let the love and awareness sound gently kiss your ears on Caroline.
I expect a few of you are wondering exactly how ampliphase works. Well, basically, each of the two 25k transmitters are phase modulated with a quiescent phase difference of about 135 degrees, then modulated in opposite directions to plus or minus 45 degrees, giving maximum and minimum differences of 180 and 90 degrees. The two carriers are fed into a combiner where at 180 degrees the two carriers cancel out and give peak negative mod, and at 90 degrees the two carriers add to give close to 100% positive mod. Shimples. Although it wasn't that simple, because adjusting it could be a nightmare, so much so that many engineers called it amplifuzz.
On top of the cage you'll see there's a tuning coil where they could match the correct length of the quarter wave vertical above to the exact frequency that Caroline was transmitted on. So it's a bit like an antenna tuning unit to make sure it was perfectly matched for the signal that was leaving the transmitter room.
That is what you call an AM transmitter?
Yeah, and it's very reliable. It was on for years and years and years without any real problems.
319 Radio Caroline.
Compared with the insulator on the end of my G5RV, this is a fairly impressive beast, isn't it?
It certainly is, but your G5RV doesn't have to take 50 kilowatts. When we just looked at the antenna matching unit downstairs on top of the cage, the copper feed from that is actually coming up through the centre, and you see to the top there, that's where the wire quarter wave vertical supported by the tower would be joined onto.
So you've got a heck of a lot of power coming up here, and we've got the ship rolling about and the sea spray coming in over the side. What kind of an effect does that have?
Well, it used to arc and spark and very occasionally trip out, but not often.
Yeah, and you could sometimes hear the clunks, couldn't you?
Yes.
On air.
Yes.
Amazing. Interesting that the engineers had to spend their time in the darkest, smelly, hot part of the ship.
Yeah, but they were very professional and dedicated, and in the 50-year history of Caroline, no one's ever been seriously hurt, which just shows you how well they worked.
And it also shows you that it's no small operation starting a professional broadcasting station on a ship. It must have costed a lot of money and a lot of technical expertise.
Yep, it's only a small ship, but it was heard by the whole of Europe, so they did very, very well.
CQ, this is Golf Bravo 5, Radio Caroline. 2 Echo 0 Kilo Papa X-ray.
I've visited some special event stations in my time, but never one quite like this, Tony. So forgetting the 50 kilowatts going up the broadcast mast back there, what antennas have you got for GB5RC?
Well, directly behind you we've got a 15 metre quarter wave that we're using. The next one is a 40 metre quarter wave, and then the last vertical is a 20 metre quarter wave, each with filters fitted to the bottom. Behind me is a 20-foot alley pole supporting the centre of a 40 metre dipole, and up on the top of the bridge is a 20-foot alley pole supporting the centre of an 80 metre dipole that runs most of the length of the boat. And also on the bridge is a 5/8 wave for 10 and a dual band collinear for 2 and 70.
So you've got all the bases covered, and this is
Yes.
an amazing place for laying out antennas, isn't it?
It certainly is. Everything is metal, so everything is grounded. Whenever you bolt your aerials to them, they're perfect, and it's floating in the sea.
As I was driving in, I was going past Reading on the M4, and I worked GB5RC. I think it was you on the mic.
That's right, it was.
And it was a monster signal. Which antenna were you using?
We were using the wire dipole you see behind for 40 metres, which was running 400 watts up from the mess room downstairs. And luckily, when the tide changes on the boat, at the moment the tide is going out, or when the tide is coming in, the boat always faces north-south. So as you can see from the dipole, maximum radiation is east-west, which is Europe and North America.
Ooh, and what wouldn't we give, all of us, for an antenna system like this on a ground plane like this? Just think of the DX you'd work. I'll tell you what, in terms of radio broadcasting, we cover all the bases. We've sat in the studios at BBC Radio 4, and now we're sat in one of the Radio Caroline studios. Wow, this is it. Now I feel at home. And actually, this is a bit more modern than it would have been in the days when they were broadcasting from the Ross Revenge, when they were out in the North Sea, because as with most radio stations these days, all the audio is coming off computer, but it didn't used to. They would have had those, remember those spinny round black things that you had to put needles on? They'd have had those, and the marvellous cart machines. I can remember all the radio programmes that I've done in those kind of studios where you spent most of your time getting stuff out and putting it away, you know, all the ads and the jingles and the music, whereas these days it's all on computer. But I'm just trying to imagine what it must have been like for the presenters then to sit here knowing that they're broadcasting to all of Europe, and were also cocking a bit of a snook at the establishment at the same time.
Number 4 in the Caroline Countdown of Sound is called I Put a Spell on You. 19.5 minutes past the hour of 7. Don't forget that at 9 o'clock you can hear the Spider who'll be spinning Graham Webb between 9 and 12. Then between the hours of 12 and 3,
And this is how it used to be. This is the actual original Radio Caroline studio on the Ross Revenge, using this old Gates mixer. In my first ever broadcasting job out in the Middle East, used this exact same Gates desk. The point about it is you can switch different sources up different faders, and I've never had a very good memory, and I could never remember which source I got coming up which fader. And of course, we've got turntables here. This is real broadcasting. You have to get the records out yourself, put them on the turntable, cue them up and play them, and that must have been fun when the ship was rocking about. And these things, never mind the computer playing your commercial break and your jingles for you, this is what they should be on, a NAB cartridge, a little tape loop that plays itself and re-cues itself, ready for the next time you want to use it. In theory. And you used to spend most of your program getting these out and putting them away, and getting the records out and putting them away, and hoping they would all work when you press the buttons. See, you young broadcasters today, you don't know your boy. Keith, sorry to interrupt you there, didn't mean to make you jump. Sat there with your headphones on. GB5, Romeo Charlie, GB5, Radio Caroline. What sort of response have you had on air?
We've had a huge response. The pile-ups have been enormous. Queues of people waiting to talk to us. It's just been overwhelming.
Now the station is set up in what was the mess room, so when the broadcasters were on the ship, this was where they did their R&R along with the ship's crew. So we were doing some ham radio R&R in here at the moment. What gear are you using?
We've got two Kenwood TS590 SGs, a couple of laptops for the login, and two amplifiers for 400 watts on both bands.
Now this is a really good example of what amateur radio is all about, isn't it? Is not just reaching out to other radio amateurs, but doing things that raise the profile of amateur radio in a wider sense.
Yes, we've had a lot of offshore radio enthusiasts get very excited about this. The fact that there's broadcasts coming from the ship is just, it hasn't happened for many years.
As you've spoken to all the stations you've worked around Europe and around the world, what's the reaction been like from them?
Been very, very good. People have been very enthusiastic. They've told us their memories of the ship, listening to the station in the 60s and 70s and into the 80s, and yeah, very positive.
Often special event stations have less than perfect antennas, don't they? You know, you're slinging something up in a tree or around an old building, or, you know, in a loco shed. Here, you've been able to put some antennas in an amazing location. You've had pretty incredible results.
We have. We worked VK on 40 metres last night.
Wow. So when people say the bands aren't any good, it does go to show that the antenna does make rather a difference.
It makes a huge difference.
You haven't done this on your own though, Keith. A lot of people involved. Which radio club has been behind the whole project?
It's the Martello Tower Group, based just outside Clacton-on-Sea in Essex. Myself and Tony, G0 MBA, put the idea of doing this to the group, and it was absolutely unanimous. Everyone said, yes, let's go for it.
Out of all the volunteers from your club who've been here helping out and, you know, working these huge pile-ups that have developed, how have they found it?
They've absolutely loved it. Bill's never done anything like this before. We've had problems keeping him off the radio.
And how many contacts have you had so far?
Just over 1,300.
Wow. Well done. It's a truly innovative special event station, this, and it's creating an incredible stir across the world, and it's great to hear Radio Caroline on the air again.
It really is, yeah. Thank you.
Radio Caroline.
Hi, this is Bob McCready. You're listening to Radio Caroline. It's the breakfast show, just coming up to 10 to 7, and the sun is shining, the sea is flat calm. There could be a better place to be. Well, apart from in the pub. Okay, let's have a bit of music now from Del Shannon. So that's it for another episode of TX Factor. What a special one this has been, visiting the lady as she sits out there at anchor and still keeping the name of Radio Caroline alive internationally. And of course, it does remind us all that one of the big things we should all be doing as radio amateurs is thinking of ways that we can raise the profile of amateur radio. And I think the guys here from the Martello Tower Group have come up with a brilliant idea by linking themselves and amateur radio to this iconic ship and putting Radio Caroline on the HF bands and on the VHF bands. It's amazing. And to find out more about the fascinating story of offshore radio in the UK, we've put some interesting links and info up on the website too.
TX Factor is brought to you in association with Martin Lynch & Sons, the world's favourite ham store.